Talk about finding maxes and mins using critical points. Now to find critical points, we do the derivative, get 8x to the 7th minus 288x to the 5th, factor out 8x to the 5th, but then we can factor x squared minus 36 into x plus 6, x minus 6. Zero product property. So we can set this equal to 0 is a 0. Set this equal to 0 gives us negative 6. Set this equal to 0 gives us 6. Now we like to work left to right, so I'd like to look at negative 6 first, then 0, then 6. So we have to find values close to negative 6, and what we're going to do is look at their slope. And when we mean look at their slope, we're going to look at the derivative, which we know is simplified into this. So values close to negative 6 are negative 7, negative 5. Values close to 0, remember left to right, negative 1 and 1. Close to 6, 5 and 7. Now, because these are all being multiplied, this is the chosen numbers to look at. So I can go 8x to the 5th, x plus 6, x minus 6, because these are all being multiplied. And then I can just look at each number, plug it in, and see if you get a positive or a negative. So at negative 7, we get a negative, a negative, positive, positive, positive. Here, negative, rest positives. Here, negative, yes, it's a negative down there, and a positive. Now multiplying across. If we have a negative times a negative times a negative, gives us a negative. So at negative 7, we have a negative slope. Then at negative 5, we have negative, positive, negative. Well, negative times positive is a negative. Negative times a negative is a positive. So it goes from negative 7 as a negative slope. Then at positive 5, it turns positive. So what do we have there if it goes negative to a positive? We have a minimum at negative 6, because negative 6 in between them. Same idea applies for negative 1 and 1. So negative 1 multiply across, you get a positive, we get a negative. So we go with positive slope to negative. We have at x equal to 0, a maximum. Then at 6, the value is close to 6. We have a negative times a positive. And so we have a negative slope to a positive slope. Well, a negative to a positive gives us a minimum. So at x equal to 6, we should have a minimum. Pardon me for having maximum. So in the graph, when we actually look at it, at x equal to negative 6, you would have a negative slope to a minimum, positive slope, and then we go to a maximum, back to a negative slope, minimum, back to a positive slope.